Assalamualaikum warahmatullahi wabarakatuh. My name is Zarif Rakim Zamani, and we as a group going to discuss an assignment that actually were really challenging for us in the ELC 1313 microprocessor course. So our lecturer have assigned us a mini project that not only push us to our limit but also bridge the gap between abstract knowledge of microprocessor and practical implementation. This project was not just any assignment, it was a comprehensive task that required us to utilize everything we had learned so far in this course, from understanding microprocessor to programming and interfacing. This project encapsulated it all. While designing and developing a project of this complexity could be daunting, the lecturer in class really helped us grasp the fundamental concept of microprocessor. And through this assignment, we have not only deepened our understanding of microprocessor, but also gained valuable experience in problem solving, project management, and teamwork. It has been an exciting journey of learning and growth, and I am excited to share more details about our project with you.
Alright, so we're going on for project operation for part A. This is me, Haziq bin Abdul Wahab, D0122100034. In this part, the input devices are switch 1 and switch 2, which are connected to the microcontroller. The output components are LEDs or LEDs. Firstly, when users presses switch 1, the LED 1 will be light up, followed by LEDs 2, 3, 4, 5, 6, 7, 8, and returning to LED 1. The LEDs create visual effect when they turn on in cycle, providing feedback that switch 1 has been pressed. This LED cycle will continue to light until switch 2 is turned on. If switch 2 is turned on, all LEDs will turning off.
My name is Faris Ridwan and my matrix number is D0123100194. So I will explain about project operation for part B. So the project overview, this project used to input components, which is a switch and a button, and two output components, LEDs and a bar display. The system simulates a car horn and light control. Switch acts as the car light switch. Button control the car horn. LEDs and bar display provide visual feedback and alert to the driver. So the operation for part B is the system start by initializing all components to their default state. Next, it then enters a loop where it's constantly check the switch and button state, and the switch state is shown on the 7 segment display. And lastly, the button state is invert, 0 become 1, 1 become 0, and used to control the LEDs.
So this is the flowchart for part A. It first start with initializing the series control, and in the main loop, it checks switch condition, and if switch 1 is on, then all LEDs are in the on condition. Then if it's no, the is check switch 2, with which it will turn off the LEDs. For part B, the flowchart will start by initializing program, and it will read the switch state and display the switch values on the 7 segment display. It will then read the push button, and if the button is pushed, then the LED will, in the on condition, will continue to look on this program. So the application for task B, at the start, all outputs are in off conditions. Input from switches will give output to 7 segment display, while input from button will give output to LEDs. The switches input and the 7-segment display output is an equivalent to turning light on and off. For example, it can be used for such as car to turn on signal or light. For button input and LEDs output, it is similar to giving temporary signal. In car application, LEDs are basically car horn that we control using the buttons. In essence, this program tries to emulate the basic function of giving signal. The analogy used is that of a car on which the switch are akin to light or signal, while the button are car horn. For input and output of usage for part B, the input that is used is switches and button. It is available in the Easy60K simulator. Ladies are and one 7-segment display is used as outputs. Although the system is simple, it is very versatile and act the basic for many applications. For example, 7-segment display can be used to display various letters and numbers.
So we can conclude that this project successfully demonstrated the practical application of the MC68000 microprocessor in controlling outputs such as LEDs and bar display using input like switches and sliders. By creating and running the program in Easy68K and testing it without the need for hardware, we were able to confirm that it performed exactly as expected. The LED responded accurately to switch input and the bar display adjusted smoothly based on the slider's position, effectively meeting the project objective. To ensure the accuracy of reliable of our program, we took careful measures such as double-checking memory addresses to ensure correct input and output mapping. We also tested the program in small, manageable steps during development, allowing us to catch and correct small errors before they escalated into larger problems. By clearly commenting our code, we made it easier to understand the bug, which was crucial during the testing phase. Various input conditions were tested to verify that the program operated smoothly with minimal issues. Overall, we successfully completed the project, achieving the desired outcome with minimal problems. This project has been a valuable learning experience for everyone involved, reinforcing our understanding of microprocessor control, and solidifying our skills in developing and testing microprocessor-based systems. Thank you and bye-bye.